Hi everyone, in today's challenge we are going to solve this problem. The problem name is Maximal Network Rank and the problem number is 1615. Alright guys, so first of all what we are going to do? First of all we are going to clearly understand the problem statement. After understanding the problem statement then we will move to the logic part, and in the logic part we are going to see how we can solve this problem. What are the logic and algorithm we are going to use to solve this problem. So everything we will discuss in the logic part, and after understanding the logic part then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I'm gonna write in this video for Python, C++, Java, and JavaScript programming language, I will share one link in the description. You can go through that particular link. You can find all the solution over there, right? Alright, guys. So now let's see what this problem says. So let's understand the problem statement. So let me remove all these things. Fine. Now let's see what this problem says. So problem say there is an infrastructure of n cities with some number of roads connecting with these cities. So guys, first of all, one thing is clear that there are n cities present, right? So input one is nothing but is going to be integer, that is nothing but n, right? This will be telling that how many cities are present, right? Fine. Second thing is nothing but that there are some roads with these cities are connected, right? So second input is nothing but we can say input two is going to be array of 2D array, let's say array of array, let me write here array of array, that is nothing but we can say roads, right? So these roads are connected with these n cities, right? After that, each roads of I, a of I and a of I comma b of I indicate that there is a bi-directional road between cities a and b. So let me just make a simple demo. Let's say there are three cities, n is 3, right? So there are three cities, so let's say this is a one city, this is a second city, and this is a third city, right? Now if roads array is look like this, roads, it's a roads, it's array is going to have on each index what is going to have, it's going to have two value on each index, it's going to have a and b, right? So let's say 1 comma 2, or let's say 2 comma 3. So 1 comma 2 is nothing but we can say there is a road between 1 to 2. You can see a comma b indicates that there is a bi-direction road between city a and b. So 1 to 2 means nothing but there is a road, let me make a road, there is a road between 1 to 2 city, and this is bi-direction, right? This is a road between 1 to 2 and 2 to 1, means you can go from 1, you can go to 2 from 1, and you can go to 1 from 2, right? So there is a bi-direction road, so you 1 to 2 you can say, or 2 to 1 you can say, right? Fine. Now the network rank of two different cities is defined as the total number of directly connected roads to either the city. Now understand this term network rank. This is the main term which we need to do in this particular code, right? What is network rank? Network rank of two city, any two city, right? Network rank of any two city is defined as total number of directly connected road to either city. So first of all, if I want to, let's make a one more road, 2 to 3, right? Now if I want to find a network rank of 1 and 3, right, it could be of only two different city, right? You can see network rank of two different city, right? So network rank of this two city 1 comma 3 is going to be the number of the number of road directly connected to this node or these cities, right? So how many roads are connected with one? There's directly one road connected with two, right? That is one road, this road is only connected with one, and so we can write here one only. And for 3 also there's only one road connected with it, which is this one, right? So I can write here this. So total number of roads which are connected, that is nothing but 1 plus 1 is 2, right? So I can say the total number of directly roads connected with 1 and 3 are 2, right? I hope it makes sense. So we can say this is nothing but a network rank. Network rank of 1 comma 3 is nothing but 2, because there are only two roads that are directly connected with 1 and 3, right? Now they are also say if a road is directly connected to both the city, it is counted only once. Let's assume there is a one road between 1 to 3 as well. So now if you will again calculate this one network rank, so how many roads directly connected with one? Now you can see there are two roads directly connected with one. This is the first node, this is the second node, right? So I can say for one there is a two node. For three also there is a two road. One is this one and second is this one. There are two roads which are directly connected with three. So now if you will say this that network rank is going to be now 4, right? Because 2 plus 2 4. But it is not the way. 2 plus 2 is 4, it's fine, but they told us that if a road is directly connected to both city, then it is counted only once. So 1 to 3 we are going to count only one, right? Only one time. Here we are counting two times, right? But here we have to count only one time, so we have to decrease by one. So we can say it is nothing but 3. 4 minus 1 is 3. So network rank here is nothing but 3. Network rank of 1 and 3 is also is going to be 3, right? Now maximal network rank. Now let's understand this maximal network. We have understood the network rank, right? Network rank is nothing but total number of directly node connected with a city A and city B, right? And now maximal network rank is nothing but the rank of infrastructure is the maximum The maximal network rank of the infrastructure is nothing but the maximum network rank of all pair of different city. Now, as we have taken a 1,3, right? You can see, guys, here we have taken a 1,3. Now, how many pairs you can get here? So first pair we got 1,3. We can also take we can say 1,2. We can also take 2,3. So there total 3 pair are present, right? So now what we need to do? We need to find the network rank of this pair, and this pair. Now once we found, let's say this is nothing but we can say 3, assuming, right, it is a wrong, right? First of all, I'm mentioning that this is wrong. Let's say this 4, let's say this is 2. So now we found the total network rank of all the pairs, right? Now once we found all the pairs, we have to find the maximum one, which is nothing but we can say 4. So this is nothing but called a maximal network rank. These are network rank of this pair, network rank of this pair, network rank of this pair. And out of these network ranks, we have to find the maximum, and that is called a maximal network rank of our this infrastructure. This infrastructure. Right. I hope you understood this one as well. So there are two terms only. One is network rank, second is maximal network rank. Now, given the integer n, now we are given an integer n and the array rows, right, which we have already seen. This is n, this is rows. Return the maximal network rank of the entire infrastructure. I hope you understood what this problem says. Problem says we are given n number of cities, we are given roads, which road is connected to which city, right? And now we need to find the maximal network rank. That means nothing but first of all we need to find all the pairs. After finding all the pairs, we need to find all the network rank of all these pairs. And after finding network rank of all these pairs, we need to find the maximum one, and that is going to be called as maximal network rank. If you have any kind of doubt, don't worry. This is just a problem statement, right? We are understanding the problem statement, not logic, right? But I believe now you understood the problem statement. Now let's see the example one and example two, and there we are going to understand this problem statement in detail, right? So in the example one, we are given this graph, right? You can see, guys, in the image we have this graph in example one. Fine. So here you can see we have to find a maximal network rank. That means we have to consider all the pairs. So here how many pairs we have? 0, 1 is 1 pair, 1, 2 is 1 pair, 0, 3 is 1 pair, 1, 3 is 1 pair, 3, 0 is already taken because 0, 3, 3, 0 is the same thing, right? So there are 4 pair, right? What I can see from now, 1, 2, 3, yeah, there are 4 pair. Now we have to find the network rank of all these pair. Then we have to find the maximum one. So if you consider 0 for 0, 1, the network rank is going to be what? For 0, 1, how many directly node connected with this 0? For 0, there is 2 directly node connected. For 1, there is also 2 directly node connected. Right? I have it making a sense. So for 0, let me see. For 1, there is no direct 2, there is 3 direct node. Right? So I hope you're getting this point. For 0, there is 2 road connected, right? For 1, there are 3 roads connected directly. Right? After that, we have to add this. So there is only 5. But you can see there is one common road which we have counted for both 0 and 1, right? So we have to count this only once. So we have to decrement by 1. We have to set is 4. So for 0, 1, we got 4. So let me just write here. Let me remove all these things because we have already understood this one. So what I'm going to say, I'm going to say 0, 4 is nothing but 0, 1 is nothing but 4. Now let's see for 1, 2. For 1, 2, this particular. So for 1, we are having a 3. For 2, we are having a 1 only. Right? 3 plus 1 is nothing but 4. But this road has only come twice. So we have to count this only once. So 4 minus 1 is nothing but 3. So for 1, 2, the network rank is nothing but 3. Fine. Now let's see 0, 3. For 0, 3, this one. So for 0, there are 2 roads directly connected. For 3, there are 2 roads directly connected, and this is a common. So we have to decrease this. So 2 plus 4, 2 plus 2 is nothing but we can say 4. 4 minus 1 is nothing but 3. So for 0, 2, 3 as well, we have 3. Now let's see one more thing, that is nothing but 1, 3, the last one, 1, 3. So for 1, we have 3. For 1, we have 3, right? 3 roads directly connected. And for 3, how many roads is directly connected? For 3, we can say there is 2 roads directly connected, right? I will make sense. So 3 plus 4, 3 plus 2 is going to be 5. And we have to decrement by 1. Why? Because this road has come twice, right? So we are going to say decrement by 1, that is nothing but 4 now. So 4, we can say for 1, 3, there is nothing but 4 network rank, right? So we have taken all the pairs and we have found the network rank of all these pairs. Now out of these 4 network rank, we have to find the maximum, which is network 4, and that only we have to return it. And you can see in the output as well, the network rank of the cities 0 and 1 is 4, as there are 4 roads that are connected to their either 0 or 1. The road between 0 and 1 is only counted once. So simple definition, guys, but we have seen the output, right? So you can take this 4 as well, both are same thing, but we have found that the maximal network rank is going to be the maximum rank of out of these possible rank, right? I hope it making a sense, right? So this is the only, guys, thing I will say. And now what we can do, we can say simply return 4. So we have done this particular problem, example 1. Now let's move to the example 2. In example 2, we have this particular diagram, right? We can say figure. Fine. So n is 5 here, means nothing but there are 5 cities and there are some roads exist, right? I'm taking a much time over here because I want you to I want you to understand this particular problem statement in detail, because the logic is going to be really easy if you understood the problem, right? So n is 5, right? So there are 5 cities and there are some road connected. Now we have to find possibly for all the this pair, for this pair, for this pair, for this pair, for this pair, and for this pair. We have to find network rank of all this pair. And after finding all this pair, we have to find the maximum one out of all this network rank. And that is going to call a maximal network rank. And if you'll focus here, then for this one, 1 comma 2, you will get a maximum rank. Because 2 is having a 1, 2, and 3. 2 is having a 3, and 1 is also having a 3, and this has come twice, so 3 plus 3 minus 1 is nothing but we can say 5. So this is nothing but called a maximal network rank. Out of all the possible network rank, we've got one network rank which is having a 5, which is the maximum. So we are going to return 5. I hope it makes sense. And let's move to the next one. This is the 8. I'm not going to do this one here, but I believe guys you can easily do with your in your copy, pen, or anywhere. Just try to do by yourself. Make a graph of 8 cities. There are going to be 8 cities, so mention 1, 2, 3, and try to connect the roads between them by using this roads array. And after that, try to find out what is the maximum network rank, right? Fine. So that is only the problem statement. We have seen the problem statement. We have seen the example. And if you want to see the x constant, you can see here, n will not more than 100. Fine. So that means nothing but our 10 is n square logic will work easily, right? N cube will also work, but we are going to see the n square logic only, right? Fine. And after that, you can see everything is seems right? So there is nothing we need to take care about. So a of 5, b of 5 is never going to be same. That is makes sense because we can't have a self loop, right? Fine. Each pair of city has at most one road connecting with them. Fine. So guys, we have seen the constraint. There is nothing much. Just one thing we noticed that n is not going to be more than 100. That means nothing but n square solution will easily get passed, right? Fine. Now what we are going to do, we are going to see the logic part, how we can solve this problem. So first of all, let me summarize this. So simple thing guys, we are given one integer n, which tells us that how many cities are there. We are given one roads array, which tells us that there are some roads which are connected with these n cities, right? After that, we have to find a maximal network rank, right? Simple thing, and we have to return that maximal network rank. Now let's write a logic part. Now guys, let's see how we can solve this problem, right? Simple thing. What I'm gonna do here, I'm not gonna take much time in the logic. That's why I have to a lot of time in the problem understanding part. So let me remove all these things. Just focus on we will say focus on this particular figure, right? What I'm gonna say I have to find like all the network rank, right, of this pair as well. I have to find a network rank of this pair as well. What actually we are doing for finding a network rank, we are just saying that how many that roads are directly connected with that node, right? For 0, if I want to find a network rank of 0, 1 pair, so I'm checking just how many directly roads connected with 0, how many directly roads connected with 1, right? This is only we are doing, right? We are just trying to find directly road connected with 0 and 1. And after that, we are subtracting by -1 because this road is coming twice, right? Fine. So what I can do here, guys, I can simply say I can pre-calculate all the nodes, all the directly roads connected with each node, right? So for 0, I'm already going to calculate that there are going to be 2 roads, there are going to be 3 nodes, there are going to be 1 road, there are going to be 2 roads. So this we can already connect it, right? We pre-calculate this, we can pre-calculate all these things, right? Because this will not going to change anywhere in the future, right? Whenever you are solving this problem, this will not going to change, right? So we have already calculated, fine. After that, we are also going to calculate that whether we have a connect, we have one node connected with 0, 1 or no, right? So what I mean by here, guys, if I have 4 cities, right? There are 4 cities, right? So I'm going to say fine. So let's make a matrix of 4 city. So I have created a 4 by 4 matrix. I hope it makes sense. You can see this one. So this is nothing but we can say city 1. So it started from 0, right? So we can say city 0, 1, 2, 3, 0, 1, 2, 3. So what I'm going to do here, guys, I'm going to say fine, it makes sense. So here I'm going to say if there is a road between 0 to 1, so I'm going to write here 0 to 1. I'm going to mark it 1, and 1 to 0 also I'm going to mark it 1, because there is road between 1 to 0 and 0 to 1. This cell represents 0, 1. Right? Means there is should be a road between 0 to 1 or not. If there is a road between 0 to 1, we are going to say 0 to 1 is 1. If there is a road between 1 to 0, so we are going to say 1 to 0 is going to be 1, right? So here you can see if 0 to 1 there is a road, right? This is a road. So we can say this is a bidirectional road. Means 0 to 1 also a road, 1 to 0 is also a road, right? So what I'm going to do, I'm going to say 0 to 1, I'm going to mark 1. 1 to 0 also I'm going to mark 1. Means nothing but this will tell us that whether there is a road or no, right? After that, you can see there is a road between 1 to 2 as well. So 1 to 2. So I'm going to say this is a cell which is representing 1 to 2. and there is a road between 2 to 1 as well, because this is bidirectional. So 2 to 1 is nothing but this one. I'm going to mark it 1. Then there's a road between 1 to 3. So 1 to 3 is nothing but this one, and 3 to 1 is nothing but this one. And there is a road between 0 to 3. So 0 to 3 is nothing but this one, and 3 to 0 is nothing but this one. So you can see I have marked 1 where we have a road. We know there is a road between these cities, right? Left is going to be 0 0. So you can see we have pre-calculated all these things. I hope you are getting this. One thing is nothing but we have pre-calculated this matrix. We will calculate once we got a function, right? We will not gonna start any loop, any logic. We're just gonna calculate first of all this matrix, and also we are gonna calculate how many directly roads connected with this each node. So here it's gonna be 2, here it's gonna be 2, here it's gonna be 3, here it's gonna be 1. So these two things we can pre-calculate, right? Now once done this all these things we have calculated, now we are gonna use a loop. We are gonna traverse to each pair. We are gonna say from 0 to 1. We are gonna traverse to each pair 0 to 1, 1 to 2, 1 to 3, 0 to 3. We are going to move to each pair, and we are going to just find how many and what is the total network rank is there, right? So let's go through one this code, right? So we are saying that for I0, I less than how much? 4, because n is 4, I plus plus, right? So let's write a hen only, and from each particular, we can say city, we are going to map other city, right? For j is equal to I plus 1, j less than n, j plus plus, right? J plus plus. So here I'm going to do inside of this loop, because now I know I comma j is going to be a one pair, right? And I can take this pair. So what I'm going to say, this is a one pair. Let's say this is nothing but 1 comma 2. I is 1 and j is 2. So I is 1 and j is 2. So I will say for I, how many directly road connected? That will easily be told by this. You can see for I 1, there is a 3 road, right? For 1, there is a 3 road connected, and for 2, there is only 1 road. We have calculated this. We got 4. Now what I'm going to do, I'm going to say, is there a road between 1 to 2? So I'm going to say 1 to 2. Yeah, there is a road, because we are having a value 1 over there in this cell. Yes, so I'm going to say decrease by 1. So I'm going to get is nothing but 3. So I'm going to say the rank of this 1, 2 pair is nothing but 3. I just set in big of 1. I hope you're getting this. After because I don't need to find out the directly road connected. I don't need to find whether there is road between 1 to 2 as well, because I have pre-calculated all these things. I can now calculate in just big of 1, because I have this matrix, my matrix, which will tell if there is a road between this pair or not. And I have already calculated how many directly road connected with each of the pair, each of the nodes, or each of the cities, right? So similarly, I'm going to find for, let me remove this. Similarly, I'm going to find for all the pairs, and out of these, I'm going to get the maximum, right? So this is the simple logic which we are going to use. Let's move to the implementation part. There you will easily understand what actually we are going to do. If you're still stuck here, if you're still not getting something, don't worry about this, guys. We are going to move to the implementation, and there we are going to understand each line, right, one by one. So let's move to the first of all Python, then we'll move to the different programming languages. So guys, I'm first of all with Python, and what I'm going to do here, I'm going to say first of all define our matrix. So I'm going to say adjacent matrix is going to be nothing but initially going to have all the values 0, 4 underscore I in range of n, and I have to multiply this by 0, not 0, n, right? What I'm doing, I don't know. It's fine. So I've created one matrix. By default it is 0, right? And also I'm going to say a dictionary. So dictionary is going to tell us that never we can say never cities, right? Or we can say never roads. So whatever you can say, never roads or never city, okay. And or we can say what is the directly road. So directly road will be fine. Directly road, fine. So this is going to be a we can say dictionary, fine. Once this is done, let's make it a collection dictionary. Collections to default dictionary of integer, right? Fine. Now once these two things we have defined, now we are going to pre-calculate this two part, right? So how we can pre-calculate it? We are going to say traverse over this for a comma b in nodes. For each roads, this is going to traverse for each road one by one. So for each road, what I'm going to say, I'm going to say adjacent matrix of a comma b is going to be 1, and adjacent matrix of b comma is going to be 1. First of all, I mark it 1. Why? Because I know there is a path between a to b. So a to b is 1, b to a is also 1. Now once I mark it 1, also I have to say, I have to find the directly roads with this particular node. So for a directly road, directly we can say road of a is going to be nothing but 1. It's going to be plus equal to 1. And directly we can say road of v is going to be nothing but plus equal to 1. So what this we have done here, guys. For a, what I'm going to say, for a there is a one node with b, right? As you know, this is a road which is having us connecting a city a comma b, right? So let me just make it comment here. So here we know there is a road between a to b, right? So for a we got one directly node, right? So we are going to increment a by 1. For b also we got, this is reversible as well, right? This is bidirectional. So b to a also there is a road, right? So we also gonna have one more directly node which is connected to a, right? So I hope it makes sense. Now once this is done, then what we are going to do? So then what we can say once we have pre-calculated all these things. So then we are going to move to the our logic for I in range of n, for j in range of I plus 1 to n. This is going to have all the pairs, right? So first of all, I'm going to say result initially 0. So what is this result? Result is nothing but we can say maximal network rank, right? So what I'm going to do here, I'm going to say find first of all kind of total network rank. First of all, find a total network rank. It's going to be what? It's going to be what? It's going to be nothing but directly root of A plus directly root of B, right? So directly root of A, directly root of B. Once we calculated this, also we need to check if adjacent matrix, how we can forget this adjacent matrix of I and J, if it is equal to 1, that means we have to subtract by minus 1. So we can say just copy this one, just say minus equal to 1, right? After that we can say result should be maximum of result for this one. So we want to take a maximum one out of all the possible total network rank, right? So we have taken a maximum, and at then we can simply return result. This is the simple problem, guys. Let's see whether this we can find or not. And I believe, guys, it should work, right? It's a very easy problem. But we got an error. Why? Oh, let's see why we got this error, right? So adjacent matrix of A is 1, B is 1, fine. So total network rank is going to be directly root of A and B. If it is equal to 1, then we are subtracting by 1, then we are putting in result. So we are getting a 5, and also we are getting a 4. Something we have missed here, guys. Just want to see. So directly root of A is going to be plus equal to 1 because there is going to be one matrix. Fine. So that makes sense, right? So adjacent matrix of A of B and B of A is 1. That is also makes sense. So for 0 into underscore in n, default dict of int. But I hope it makes sense. So directly root of A plus directly root of B, if adjacent matrix of I comma j is 1. Alright, so this is the mistake, guys, right? I hope you get it. A is nothing but what? I have to use I. I don't know how it was working even. What is A? A is nothing, right? So we have I and J. I is nothing but first city, J is nothing but second city. Now let's submit this code. Finally, I got really tense, right? Now let's see whether it's getting submitted or not. You can see that it successfully got accepted, right? Let's move to the next programming language, which is nothing but C++. Let's quickly define first of all one matrix. One means array. So we can say vector of int, and here give a name adjacent matrix of n size, and inside of each we are going to have one default vector of int of how much size, n size only, default value 0. Then we are going to say make a map, so unordered map, and it's going to have an integer. The name I'm going to give directly road, and fine. So this is the only thing. Now let's travel to each city. So we can say const auto and roads inside of road. And here what we are going to do, we are going to say simply let's say int a is nothing but road of 0, int b is nothing but road of a, road of 1. So now we got both of the city a and city b. Once we got these cities, we are going to say fine, first of all put in directly road of a plus equal to 1 plus plus directly road of b plus plus. So we have now also we have to insert in adjacent matrix. Adjacent matrix of a of b is going to be 1, and adjacent matrix of b of a is also going to be 1. So I hope you're getting this part. So simple thing, guys, what we have done here. So here first of all we found both of the city a and b. Once we found both city a and b, then we are saying that this means nothing but, here we can say this means nothing but there is a path between a to b, right? There is a road between a to b. Similarly, there is a road between b to a as well, right? Now we are going to say okay, so if it is the case, so the directly road of a is going to be increased by 1, and directly road of b directly road of b is also going to increment by 1, and after that put in adjacent matrix of a comma b. That means there is a path between a to b, there is a path between b to a, right? Once we have pre-calculated this, now we are going to say define result, which is initially 0. Now we are going to say for int I is equal to 0, I less than n, I plus plus. For int j is equal to 0, let me let j is equal to 0, not 0, j I plus 1. Otherwise pair will come may j less than n j plus plus. Why I'm not starting with 0? Just let me know in the comment. It's a very easy question, right? Fine. And if I'm going to say if, not if, I'm just going to calculate the total network rank here. So int total network rank. Right. So what is the total network rank? So rank is going to be nothing but directly road connected with I plus directly road connected with j. Once we have collected this thing, Then we are going to say if adjacent matrix of I comma j is 1, that means there is a road between them as well, so we have to decrement by 1. So I can say total network rank minus minus, and once this is done, then we can simply say at the end result should gonna have maximum of result or total network rank. We are taking maximum result, right? So maximal network rank is going to store in our result, and we're going to store return our result. Now let's see whether it's working fine or not. So for each pair we are calculating total network rank. After that we are checking with result whether it is maximum. If it is maximum, store in result, right? You can see both the tests is passed. So let's try to submit this code, and I hope it will get submitted. You can see it got accepted. Now let's move to the Java. First of all, let's quickly define hash map. Integer, and why integer, right? So let's give it a name directly road, and it's going to be nothing but new hash map. Fine. Also we're going to define one array. Let's give it a name adjacent matrix. It's going to be new int of n comma n. Then we are going to say move to the each cell for int. We can simply say for int row of roads. Let me write here row, and we can simply say what? We can simply say adjacent matrix. Not adjacent. We can do like first of all let's calculate the city, right, for this road. So what are the city? First city is going to be road of 0. Second city is going to be nothing but road of 1. Right, and in adjacent matrix of A and B means there is a path between A to B. As this is bidirectional roads, there is a path between B to A as well. So B to A also 1. Fine. After that, we have to say directly road of A is going to be in the directly road to put on the A directly road dot get or default of A comma 0 plus 1. I hope we are getting this one. So let's copy this one whole thing because we don't want to write this much again and again. So I will say simple here B. If you are inserting first time, so you have to take 0 value, otherwise take that value and increment by 1. So once we have pre-calculated both these things, adjacent matrix and directly road, then we are going to find out all the pairs. So we can say int result initially, which is going to be store our maximal network rank. After that, we are going to say for int I is equal to 0, I less than n I plus plus, and for int j is equal to 0, not 0, I plus 1, j less than n, j plus plus. Why I plus 1? Because we want to, what we want to do, we want to take a different pair every time. If we take a 0, then pair will get repeated, right? Fine. So after that we can say if if get the total network rank. So int note this one, total network rank, right? So when is fine. If it is the case, what is going to be total network rank? Total network rank is going to be directly road get or default of this I comma 0, right, plus. Let me copy this whole thing again. Directly road of j. If it is not present, then take it 0, right? So we go to total network rank. Now we're going to check if adjacent matrix of this I and j is 1. If there's a road between them as well, so we have to take a decrement by 1 because we want to take that road only one time. So we can say fine, send total network rank is minus minus. And then what we need to do, we need to check. After this pay, we need to check. Result is going to be always math road maximum of result or total network rank, right? Once this is done, and then we can simply return our result. Let's see whether it's working fine or not, or do we have any mistake in this code. Okay, so it's taking a time. I think you can see guys all the test case passed, so let's try to submit this code, and I believe guys it will get auto submitted. Submit, let's see. And you can see guys it got accepted, right? Now let's move to the JavaScript, and in the JavaScript what we are going to do, first of all I define directly road dictionary or map, or we can say new map, right? Fine. Then what we are going to do, we are going to say let's make an array. So the name we are going to give adjacent matrix is going to be nothing but array from length n comma, and here we can say is going to be new array dot fill array of n size dot fill 0. So we have created one 2D array of adjacent for adjacent matrix. By default value is 0. Now we're going to say let's move to all these things. So we can say const a comma b, const of this roads, right? And here we're going to say fine, once we go to this road, so what we're going to do, we're going to say for each we are going to pre-calculate the directly road and adjacent matrix. So first of all we are going to say adjacent matrix of this a comma b is going to be 1 because there is a road between them, and adjacent matrix of b comma a is also going to be 1 because there is a road between them as well, because this is bidirectional a to b and b to b. Fine. Then what we are going to do, we are going to say directly road is going to be nothing but what? Directly road is going to be nothing but what? Directly road we have to set for this a. What you are going to set? You are going to set what? Directly road dot get for this a, or you are going to say 0, right? Fine, I think it should work. Let's see. And same thing we are going to do for b. Directly road dot get b. If it is giving a null, then you have to say take 0. Fine. So after doing all these pre-calculation, then we are going to say let result is 0, and we are going to say 4. Let's say let I is equal to 0, I less than n, and I plus plus 4. Let j is equal to 0, j less than n, j plus plus. Then what we are going to do? We are going to say fine, not 0, j is equal to I plus 1. We want to take always unique pair. Fine. For this pair, we are going to calculate the total rank, total network rank. Is going to be what? Total network rank is going to be directly load connected with A and directly load connected with B. Not A and B, I and J, right? So we are going to say directly load dot get for I. If you are not getting, then what you're going to say? You're going to say 0, right? So let me take in this particular thing in bracket, and I'm going to say copy this, and not here. What I'm doing, paste it over there, right? And here I'm going to say with J. Right, once we have added the total network rank, now we're going to check if our this we can say this I to J, this city road is connecting, this I is nothing but a city, right? J is also a city. So between this city also we have one road. If this is the case, if adjacent matrix of I and J, if there is a road between I to J as well, then we are going to take only one time that road, right? So we have to decrement by 1. So if I of J is nothing but 1, then what we are going to say? We are going to say total network rank is going to be decrement by 1, right? Fine. So at the end we can say result is going to be method dot maximum result and total network rank. Every time we want to take a maximum, as we have to return the maximal network rank. At the end simply we can return result. Let's see guys whether it's getting a pass or not. So I believe guys it should work, right? Let's see. And we got a wrong answer each time. So we are getting a 0. Why is this the case? So let me see for second case as well. Fine. So do we know the reason why we are getting a 0? Total network rank is decremented by 1. Total network rank is going to be times 0. So to get I, if you are not getting, then take 0. Then not good, get J. If you are not getting, then take 0. Fine, it should work, right? Let's see again. Just give me a second, otherwise. So what I can see on my cheat sheet. Do we have any other function for I don't think so. Just give me a second, guys. I'm just checking whether for JavaScript we use anything else. Yes, the thing we have seen, right? So the issue was nothing but the this directly road don't get in. So we are taking this. We are not adding 1 into this, right? So what I can do here, I can simply say actually once we have we know this particular thing. Let me just write here only. If there is a road between A to B, right? So we know that guys, one road is going to add in this A as well because there's a one directly road, and there's a one directly road with a B as well, right? So we're going to add in A and B as well. So what I'm going to do, I'm going to say simply plus 1. So this is what it's going to do. It's going to increment by 1, right? Now if we see this, now we'll not get 0, right? So let's see. You can see all the test case pass. It's simple thing, guys. We were not incrementing A and B road, right? So that we have done now. Now it's going to pass. Now let's see whether it's getting submitted or not. And I believe it should get submitted. Let's see. And you can see guys, it successfully got accepted. So we have done the implementation with Python, C++, Java and JavaScript. If you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.